Good day to all of you. Through this video, we will be discussing about the second part of the lesson, Force and Pressure, Class 8. Before you watch this video, make sure that you have already watched part 1 video of the lesson, Force and Pressure. In today's session, we will be discussing the following topics. How to represent a force. How can you find out a resultant of force? What are the classifications of force? How can you classify force into contact or non-contact force? What is meant by muscular force, frictional force, magnetic force, electrostatic force, and gravitational force? First, let us look into a representation of force. As you can see in the picture, there are two boxes, and on both the boxes, I'm trying to apply a force of 10 Newton. But as you can see, the arrow mark is showing two different directions in which I'm going to apply the force. Based on the direction of my application, result will be different. In the first case, it might be possible that the box will be crushed into a different shape. But in the second figure, when I'm applying a force from right to left, the box might be sliding over the floor, which means the effect of force will be different even though the magnitude of force is same, because force depends on both magnitude and direction. Even though in both the cases I am trying to apply the same force as 10 Newton, but the result is different because the direction of force is different. So in order to represent any force, we need to consider two factors. One is its magnitude and another one is its direction. If the direction or magnitude of the applied force changes, its effect also will be changing. As you can see, along with the number 10, I have written a symbol capital N, and it will be read as Newton. That represents the unit in which you can measure the force. As we know that every physical quantity will be having certain units. You all might have studied meter is the unit of length, kilogram is the unit of mass, and so on. So here, Newton is the SI unit of force, and it can be represented by using the symbol capital N. Now, have you ever wondered why is it easier to cycle during sunny days than during windy days? You might be feeling so easy to cycle during a sunny day if the wind is not there. But at the same time, if there is a wind, especially in the opposite direction of your pedaling, you might have felt it is very difficult to pedal the cycle, right? What might be the possible reason? Let us look into the reason. Now, in both these cases, when you are pedaling a bicycle, there will be two forces acting on the bicycle. One is, I have mentioned here by using an arrow mark, F1. F1 stands for the force applied by you on the bicycle, that you are trying to pedal the bicycle in the forward direction. That is why the direction is given from right to left. At the same time, there will be another force acting on the bicycle. It will be air resistance when wind is flowing in the opposite direction. So this will be the second force acting on the bicycle. What is the speciality of these two forces? As you can see, these two forces are acting in the opposite directions. So these forces will try to oppose each other, and obviously the one who is stronger will win, right? Here also, in the first case, the one who is stronger is the force applied by you, because in sunny days there won't be so much wind, it might be just a breeze, so the air resistance will be very less. But on the other hand, in the second figure, you can see you are applying a force from right to left, but the air resistance is coming from left to right. In a windy day, the force applied by wind or the force applied by air will be big in comparison with a sunny day, which means in the first figure, the force which you are applying is big and the force which the wind is applying is small. So the effort you have to take will be less. But in the second figure, both the forces are strong enough. So in order to overcome the air resistance, you have to increase your force with which you are pedaling a bicycle. That is why it might be difficult to pedal a bicycle on a windy day, especially when the wind is blowing in the opposite direction of your journey. Now, see, in this figure, you can see there are two teams who is playing the tug of war game. Now, you can see both the teams are equally strong, which means if F1 is equal to F2, there will not be any movement to the rope. We have studied in the first class that a force can move a standing object. Here the rope was stationary before the teams were applying force. Even though both the teams were applying force, the rope is still stationary. The reason is both the forces are acting in the opposite direction. So there is a possibility that the object will be stationary even though force is acting on it. The condition is if the object is acted upon by two equal and opposite forces. Fr, here Fr represent resultant force. If more than one force is acting on an object, resultant force can be found out either by adding both the forces or by subtracting the forces. See, as you can see in this figure, F1 is acting from right to left and F2 is acting from left to right. That is, both the forces are acting in the opposite direction. In this case, resultant force will be difference between the two forces. Since we are depicting a case where F1 is equal to F2, here the resultant force will be 0, which means the object will not move. Now let us look into this example. Here both persons are trying to push a car in the same direction. Here, resultant force will be, as you might be experiencing, that if one person alone is pushing the car and the second person is joining hand in hand, what happens? The act of pushing the car will become easier. The reason is here both the forces are acting along the same direction. Therefore, resultant will be sum of the two forces, that is F1 plus F2. Direction of the resultant will be along the direction in which both the forces are acting. So we came to three different situations. One is when two forces are acting in the opposite direction, resultant will be difference between. Now the second special case is if both these forces which are acting in the opposite direction are equal, then the resultant force will be 0. Now the third case is if two forces are acting in the same direction, then the resultant will be sum of the two. Here are the conclusions what we discussed so far. Resultant force will be the sum of the two forces if forces are acting along the same direction. And in that case, the direction of the resultant will be same as that of each of the forces. Second case is if two forces are acting in the opposite direction, then the resultant force will be difference of the two forces and the direction of the resultant will be along the direction in which the larger force acts. And thirdly, the net force on an object will be 0 if two equal and opposite forces are acting on the same object. So this is about representation of force, how to find out resultant of force when more than one force is acting on an object. Force need both magnitude and direction for its representation. Resultant depends on the direction of the individual forces. Now, let us look into what are the classification of force. Force can be mainly classified into two categories. One is called contact force and the second one is called non-contact force. There are a few examples of contact force I have mentioned here. One is muscular force and the second one is frictional force. Whereas the non-contact forces which we will be discussing in this lesson are magnetic force, electrostatic force and gravitational force. Now let us discuss what makes the force to be called as contact or non-contact force. In the first session, we discussed about what are the conditions for force to be acted. In that, we stated two conditions. One is there must be at least two objects, and second one is there must be an interaction between the two objects. At that time itself, I've told you interaction can be in two ways. One is, and both the objects can come in contact with each other and they can have an interaction. Secondly, need not be a direct contact. In the case of magnets, magnetic materials, when they are kept nearby also, that force of attraction or repulsion can be felt. So those types of forces which do not require any direct contact between the two objects will be called as non-contact force. Let us look into some examples and classify whether they have a direct contact or they do not have a direct contact. In this, you can see a farmer and bullocks. The farmer is having a contact with the bullock, not directly, but through a connector, right? So contact force can be a direct contact or contact through a connector. So this picture represents a contact force. Let us look into another one. In this, you can see an apple is falling down. This is one of the famous incident you all might be knowing, that it came to, or it leads to the invention of gravitational force. So when an apple is falling down, why the apple is not going up? Because earth is attracting the object. It is an example of gravitational force. See, when earth is attracting apple, earth is not going and touching the apple, right? So this force is acting through space. There is no need for a direct contact, which means this will be coming under the category of non-contact force. A man is pedaling a bicycle. He is applying the force on the bicycle. He can't do this without having a direct contact. So it is an example of contact force. Now you can see a girl is holding two buckets of water. For this also, she has to touch the buckets, which means it will be coming under the category of contact force. Now let us look into another example. You all might have done this experiment. If not, please try to do it today from your home, that you can comb a dry hair with a plastic comb, and after combing for several times, keep some small bits of paper, and when you bring the comb near to the bits of paper, it is not needed to be touching. So when these comb is coming near to the bits of paper, the bits of paper will start attracting, sticking towards the comb. So it is an example of non-contact force. Another one is magnet is attracting steel balls. Definitely direct contact is not needed. So this is also an example of non-contact force. So from these examples, you all might have come to a conclusion about how to define contact or non-contact force. Contact force can be defined as the forces which act on a body either directly or through some connector. Examples of contact force are muscular force and frictional force. We will be discussing about muscular force and frictional force in detail in this session itself. Non-contact force, on the other hand, can be defined as the force which do not make a direct contact, and it can act through space without any connector. So they are called non-contact force. Now, let us look into the examples of contact force, the first one being muscular force. Muscular force means it is the force produced by the muscles of living beings. Whatever work you're doing in our day-to-day life, it all requires our muscle power. Whether you are writing or jumping or lifting a heavy object or pushing a table, opening a door, in all these activities, muscle power is required. We are performing the work, or we are applying the force with the help of our muscles. So those forces which require the muscular power, or these forces are produced by the muscles of living beings. It is called muscular force. Muscular force is a contact force because every time when you have to apply force with the help of your muscles, you should come in contact with the object. You can't open the door without touching it. You can't push a table without touching the table, right? So muscular force will be coming under the category of contact force because muscular force always require a direct contact between the two objects. Or sometimes suppose you are trying to hammer in a nail into the wall. So at that time, you might not be touching the nail directly, but you are having a connector. The hammer is the connector here. So you are applying a force on the nail with a connector called hammer. So that also will be coming under the category of contact force because contact force need either a direct contact or a contact through a connector. So muscular force is an example of contact force. We'll see what are the examples of muscular force. In which all events we say that the force is muscular. Example is lifting a heavy weight, pushing a lawn roller, ploughing a field with the bullocks, driving a nail in the wall with hammer. All these events are examples of muscular force. The second type of contact force is frictional force. In order to discuss what is friction, let us look into the picture. There are two situations depicted. In situation A boy is trying to come down an icy surface. In the second picture, the same boy is trying to come down in a grassy surface. You all might be knowing that which event will be easier. The event easier will be case 1 or case A because when you compare the two surfaces, one is icy surface, another one is grassy surface. When you compare these two, icy surface is very smooth, whereas grassy surface is little rough. So when you are applying a force, when you start moving on the surface of these two, there will be some invisible force which will try to oppose our motion. That invisible force which oppose our motion when any object start moving on the surface of any other object is called a frictional force. So speciality of frictional force is it will be always trying to oppose our motion. For example, see this is a football. When the football is rolling on the ground, it is not needed that somebody has to stop the football. Even if nobody is there to stop the football, after some time of its roll on the ground, it comes to an automatic stop. The reason is there will be an invisible force which is acted by the ground on the ball, which will try to oppose its rolling motion. So that is frictional force applied by the ground. Another scenario is when you're rowing a boat in a still water. If you stop rowing the boat, what happens? After some time, you come to a stop. The reason is here the force of friction will be acted by the water. Boat comes to rest if we stop rowing it because water will oppose the motion of the boat. In this, when you're pedaling a bicycle on a horizontal surface, okay, not on a slanting surface, on a horizontal surface, if you stop pedaling, what happens? The bicycle will come to a stop. The reason is there will be an opposite force applied by the road on the bicycle. So in all these situations, what is common? The common thing is one object is trying to move on the surface of another. In the first picture, ball is trying to move on the surface of grass. Second one, boat is trying to move on the surface of water. Third one, cycle is trying to move on the surface of road. In all these three situations, one object is moving on the surface of another. When doing so, an opposite force will come into play. That opposite force is known as frictional force. So let us define friction as it is the force which acts at the surface of contact when one body moves or tends to move upon another body. That force is known as frictional force. So we discussed about what is muscular force and what is frictional force. Both these need a direct contact between two objects. That is why both of them are classified as contact force. Now, let us look into another type of force. It is magnetic force. As you know, there are some materials like iron or steel, they will have the tendency to move towards magnet. So this property of these objects are known as magnetic properties, and the force exerted by the magnet is called a magnetic force. And as we discussed, magnet and magnetic materials will get attracted even without a direct contact. So they will be interacting through space. That is why magnetic force is categorized as a non-contact force. Now, the second type of non-contact force is electrostatic force. Electrostatic force will come into play between two charged objects. We know that there are two types of charges existing. One is positive charge and another one is negative charge. If two positive charges are kept nearby, their interaction will be repulsive. The same thing will happen if two negative charges are kept nearby. Whereas, if one positive and one negative charge is kept nearby, their interaction will be attractive. So whether it is attractive or repulsive, there will be an interaction if two charges are kept nearby, which means the force can act through space. So that force of attraction or repulsion exerted between charged particles is known as electrostatic force. As we discussed, it can be either attractive or repulsive. The same thing happens for magnetic force also. If you keep two bar magnets. Bar magnets means what? It'll be having a north pole and a south pole. If two magnets are kept this way, that is north and north facing each other, the force exerting on each will be repulsive. They'll try to move away from each other. Or on the other hand, if one north pole and another south pole is coming nearby, then the force will be attractive. They try to move towards each other. So electrostatic force and magnetic force both are non-contact force because they will exist even without having a direct contact. And both these forces could be either attractive or repulsive based on the pole or based on the nature of the charge. Now, let us look into the third non-contact force. It is gravitational force. You all might have studied this in smaller classes also, that every object will get attracted towards the center of the earth. See, one speciality or one major difference between gravitational force and the other two non-contact force is gravitational force will be always attractive. It cannot be repulsive at all. So gravitational force is the force of attraction with which all the objects are getting attracted towards each other. So even though I have shown a picture of Earth attracting everything towards its center, gravitational force can be existing between any two objects in the universe. That is why gravitational force is known as a universal force. It can exist between any two objects. It can exist between a planet and sun. It can exist between planets. It can exist between a planet and a satellite. So everywhere, any object in the universe, any two objects in the universe will have a force of attraction. That force of attraction is known as gravitational force. So speciality of gravitational forces, gravitational force do not require any direct contact. We know that Earth is not in direct touch with sun, but still there will be a force of attraction between the Earth and the sun. That is why Earth is able to revolve in fixed orbit around the sun. Otherwise, Earth might be moving somewhere else, right? So there is no direct contact required for gravitational force to happen. So gravitational force is classified under non-contact force. Speciality or one major distinction between gravitational force and the other two non-contact forces, gravitational force will be always attractive in nature. Now, we shall conclude the topics which we studied today. Classification of force, contact and non-contact forces. Contact force examples are muscular and frictional force. Non-contact force examples are magnetic, electrostatic, and gravitational force. We studied about how to represent force, how to find out the resultant force if more than one force is acting on an object. I hope today's session was very helpful to all of you. Thank you. We'll be meeting again with the forthcoming topic of the lesson, which is pressure. Thank you for watching. Bye bye.